possible without our coordinator from that organization, Sanja Stjepanovic. Please, a big applause for her. And also the other coordinator from TEDx Podgorica, Radnica Stojanovic. Another applause, please. Thank you. I really would like to thank them for their effort, dedication, and time, and also the other members from this organization for contacting the right speakers and arranging everything so this event could be possible. Also, I would like to thank the Ministry of Science for supporting the Neuroscience Day and for including it in the official program of the Open Science Days. So maybe you know the 2014 is the European Year of Brain Research. So in order to bring closer the achievements in this field of research, tonight we are lucky to have here 5 young experts in this field of research who will share with us their research experience through their personal stories. So we'll hear really 5 interesting talks which are covering the different aspects of neuroscience and have different approaches in studying the human brain. So, as you can see, we will have a short break after the second speaker of around 15 to 20 minutes. So, let's start. The opening speech will be delivered by Merina. She comes from Great Britain and she did her BA in Linguistics and Cognitive Neuroscience in the University of Utrecht. At the University College London, she is doing her her PhD research on brain basis of reading and dyslexia by using model imaging methods and network analysis. The title of her speech is How to Study the Human Mind, a guided tour from labs to networks. So we will hear why we are still struggling to find the answer on that question that has been puzzling the civilization for centuries. So let's start. I will give the floor to Merina, and here you are. An applause, please.
Hear me? Is this better? Hello, yes. I can hear myself now. Okay. Can you hear me in the back as well? Yes, perfect. This looks more inappropriate than it really is, guys. Okay. Right. Okay, thank you very much for inviting me and giving me the honor to have the opening speech. I hope you enjoyed the talk. Is there any way to reduce the echo by any chance? Hello? No? Okay. So let me just jump straight into it. So in April 2013, President Obama announced a very ambitious new initiative called the Brain Research through Advancing Innovative Neurotechnologies, or in short, the BRAIN project. And at the press conference, he made the following statement. As humans, we have identified galaxies light years away, studied particles smaller than an atom, but we still haven't unlocked the mystery of the 3 pounds of matter that sits between your ears. And I agree with this statement, and that's why it's a very exciting time to be in this field, to study the brain, because this might just be the era of the brain. More than ever before, have we highlighted the need to really study how the mind works and why it sometimes breaks down and how to fix it. Because that 3 pounds of matter between your ears right now hosts one of the most exciting, mysterious systems in existence, which is the human mind. Now, I first realized just how wondrous the mind can be when my own mother got herself an iPhone. Now, to you, this might not seem like a big event. I mean, what's so special about an iPhone in our generation? But keep in mind that my mother is someone who is nearly 60 for the past 10 years that she's had a normal cell phone for, didn't even know that the text function existed. Nor did she actually turn her phone on when she carried it with her, just to save battery. So the fact that she got herself an iPhone and knew how to use text messaging through WhatsApp and use emoticons was completely baffling to me. And when she sent me the first message with emoticons through WhatsApp, which was this, it's a very simple message, but coming from a mother like that just completely blew my mind. And that right there and then really busted the myth that the brain could not learn or form new associations at old age. But I also saw firsthand how the mind can break down when my mother had a mental breakdown a couple years ago, for which she's still receiving therapy. So she was unhappy, and her mind made associations that would lead to stress. And as a consequence, her mind came up with coping mechanisms, unhealthy coping mechanisms. But she's not the only one. My stepdad also has a mental illness. He has struggled with obsessive-compulsive disorder, with paranoid thoughts his entire life. And as the newspapers would tell you these days, they're not the only ones. There are simply 2 out of many out there who struggle with mental illnesses on a daily basis. And the most famous example of that might be the recent death of actor Robin Williams, who supposedly committed suicide after battling from depression. So, as mental illness is a disease of the mind hosted inside the brain, it is imperative that we understand the brain mechanisms involved in order to find a cure. And this leads to the question, how to study the mind, how to best study the mind in the human brain. Well, that's a really tough question. And if we knew the answer to this, I probably wouldn't be standing here talking to you. And there are many ways to study the brain, as I'm sure you hear about from the rest of the speakers today. But what the best way is depends on the question you're asking. So I'm particularly interested in mental illnesses, and I want to find out how and why the mind sometimes gets ill, and how to fix that. And I want to find new, meaningful ways to study the brain in order to help people struggling with mental illnesses. But before I get into the methods, I want to just have us take a minute to really think about what we mean with mental health and mental illnesses. What do we actually mean when we say that someone is mentally ill? I often hear the words crazy, lunatic, hysterical, just out of her mind. But these terms are not very descriptive, and they make it seem like this person is somehow at fault for not being able to control his or her mind. But that's not what mental illness really is. Mental illness, by definition, or is sometimes called a disease of the mind. But a disease, by definition, should have a clear cause, a set of symptoms, and a predictable course, which we call prognosis, all of which should be clearly understood and well studied so that we can find a cure. But mental illnesses aren't that simple. Historically, mental illnesses has been used to label those who do not fit with the norm or the mean of society at a particular time. This means that mental illnesses are defined based on symptoms rather than causes, simply because we don't yet understand what these causes are. So, therefore, we cannot predict the prognosis, and we can only offer treatment to tackle the symptoms without actually providing a cure. So, in practice, this has led to people carrying labels that do not have a biological foundation, which often leads to prejudice and stigma, that mental illness is bad, and that the mentally ill should be avoided or locked away. It's especially hard because the mentally sane can never really understand the experience unless they get ill themselves. You can sympathize and you can empathize, but that's not the same. So, this is not to say that labels are not useful. They are in practice, and we need labels to identify those in need of extra help. But what I would argue is that the way these labels are currently given is ambiguous, and that ambiguity limits good research to help these people. So, for example, in order to get a diagnosis for schizophrenia, you need to have have at least 2 of these symptoms most of the time for a period of about a month with some level of disturbance over 6 months. So these symptoms include delusions, hallucinations, disorganized speech, extremely disorganized behavior, catatonic behavior, which can range from a coma-like state to a hyperactive behavior, or negative symptoms, which mean a reduced ability or lack of ability to function normally. And at least one of the symptoms must be delusions, hallucinations, or disorganized speech. Now, just to remind you, only need 2 of these symptoms to fit the label, most of the time with some level of disturbance. But who decides what most of the time is, and who decides what some level of disturbance means? So these labels are very ambiguous and very vague. For major depression, you need to have at least 5 of the following symptoms. Most of the day, nearly every day, for a period of 2 weeks. And one of these symptoms must include a depressed mood or a lack of pleasure or diminished interest in activities. Other symptoms include significant weight loss when not dieting, or the opposite, weight gain, or simply an increase or decrease in appetite. Insomnia, or again the opposite, an increased desire to sleep. Restlessness, or slow behavior. Fatigue, or loss of energy. Feelings of worthlessness, or excessive or inappropriate guilt. Trouble making decisions, or trouble thinking or concentrating. Now, I hope you would agree with me that so far, many of us have experienced at least 5 of these symptoms at some point in our lives. Perhaps not the last one, which is recurrent thoughts of death or suicide or an actual suicide attempt. But again, I hope this just highlights how ambiguous these labels actually are. So in practice, these ambiguous diagnostic criteria have resulted in people with very different symptoms to carry the same label. And we get into this catch-22 situation where we want to be inclusive, not to miss out anyone in need of extra help, but we cannot actually make proper scientific inferences about the disease simply because we don't understand what a disease actually is. And until we understand what a disease actually is, we rather overdiagnose rather than underdiagnose. So again, undermining scientific inferences. And more often than not, people don't always get a label because they don't meet the cutoff points set in the diagnostic manuals, as in the case of my mother. So they're just defined by a set of symptoms. And why we cannot make proper scientific inferences is the way brain research is currently done, which is by comparing groups. So if you compare a group of patients with very different symptoms with a group of healthy controls in a research setting, you get very, very muddled results. And on top of all this, we miss the crucial element of treatment, which is the individual. So how are we actually doing brain research right now? So these are just some of the current methods that we're using. And it's just a selection, like I said before. There are many ways to measure the brain, but I'm only to discuss 3 here, ones that I'm using myself, and which you may have heard of or read in newspapers. So the first one is electroencephalography, or EEG. Second one is magnetic resonance imaging, or MRI. And the last one is called diffusion tensor imaging, or DTI. Now, although all of these 3 methods measure signals from the brain, they differ very widely in what the signals mean, what the signals are, and therefore what they mean. So for example, EEG uses these funny caps that you put on, and it measures electrical current from the surface of your head. So if you didn't know this before, let me just tell you right now that you have billions and billions of tiny electrical currents going through your brains and your heads right now as you're listening to this, as you're watching this. So using EEG is like tapping into the electrical circuit without actually damaging that circuit or without being electrocuted. And EEG will tell you exactly when and how fast your brain can process things. MRI, on the other hand, requires you to lie down into this big machine, and it will tell you which areas of your brain you're using when doing certain tasks. So for example, here, you see an image of a person thinking of words that start with the letter T. And mind you, the person is only thinking of these words without actually saying anything out loud. And you see the yellow and red colors that indicate which areas are actually being used. We neuroscientists sometimes call them blobs, just because it's kind of like blobs. Now lastly, diffusion tensor imaging. So if you're a Muse fan, you might have seen this before without actually realizing what they mean, but these are actually images of the brain that cover the album. Now, diffusion tensor imaging measures the directions in which water molecules can diffuse freely in your head. Now, this sounds very complicated, but the idea is very simple. Imagine all of those water molecules are cars. If you put those cars in a wide open field, they can drive in any direction they please. But if you put the cars on highways or roads, they can only drive in certain directions. So DTI measures those highways and roads in your brain and produces these very colorful images. So each of those colored lines represents a different road in your brain. So at this point you might think, well, that's great. So we know when the brain does things with EEG, we know which areas are being used with MRI, and we know what connections are between those regions using DTI. So what else do we need? How come we still haven't figured out how the brain works? Well, I'd like to argue that this is probably the hardest part about doing brain science and about doing science in general. You need a good question, because technology won't get you anywhere if you're asking the wrong questions. So let's go back to mental illness and let's consider a hypothetical case. Holly and Ben are both schizophrenic, but they have no symptoms in common whatsoever. How do we then know whether the same brain mechanism causes the illness in both Holly and Ben? And equally, if one treatment works for Holly, how do we know that the same treatment works for Ben? So intuitively, you might say, well, no, that can't be because they have no symptoms in common, so surely it can't be caused by the same thing, and the same treatment probably wouldn't work. Well, in reality, this is true sometimes, and sometimes this isn't. And equally, they carry the same label. Both of them are diagnosed with schizophrenia. So surely, if it's the same disease, you would imagine that it has the same cause and can benefit from the same treatment. And this is why our current way of doing things is limited. So one way to tackle this issue is to move beyond labels. Not away from them, because like I said before, labels are useful, but to move beyond them and actually look at individuals. So, and this is where networks come in. So the three methods I've mentioned before, EEG, MRI, and DTI, will all tell you something about an individual person's brain. So instead of then averaging those measures with measures from other people who might have very different sets of symptoms, you can construct a network of that particular person's brain and mind, which we have termed the connectome, very much like the genome. And the easiest way to think about this is to think of it as a map. For example, a map of Europe. So this map highlights certain flight paths that I could have taken to get me from London to here. So I could have flown straight from London, or I could fly via Belgrade, which is what I did, or I could have flown via road, which is a different path. And although all three of these paths will get me from London to here, they differ very widely in the path that they actually take and the regions that they cross, and also in the times. So now imagine this map was a map of the brain. In the brain as well, signals between regions can take many different paths. So if one or all of those paths are damaged, this may lead to similar symptoms, but with very different causes. So here's an example of Holly and Ben again. So imagine that the red path is damaged in Holly, but the blue path is damaged in Ben. Because both of these paths connect brain region A to brain region B, the information transfer between these regions are damaged, which can lead to similar symptoms, but as you can see, they have very different underlying causes. And equally, if our brains are inherently different and everyone has an individual map, then damaging the same connection might actually give you very different symptoms. So for example, here, the red path, which connects brain region A to brain region B again in Holly, but the same red path might connect brain region A to brain region C in Ben. So damaging that same path leads to very different symptoms. So the connectome can kind of function as your mental fingerprint. And in reality, this fingerprint will look something like this, which I guess doesn't really look like a fingerprint because it's somewhat complicated. But the colored lines you see inside the circle represents different connections between different brain regions, and the colored blocks around the circle represent brain regions. And if we reduce that to these spider-like patterns, you'll see that it does slightly resemble a fingerprint a little bit more. And when we compare connectomes between individuals instead of between groups, we get to see overlap in mechanisms that we did not observe in our symptoms. And this helps explain why certain treatments might work for certain individuals but not others. And within the group for which the treatment does not work, we can actually try and predict why that's the case, and also what other treatments might be better and more beneficial for these individuals. So although the connectome is a simplification for the complexities of the brain, it is a step forward to make those complexities more manageable and provides a new framework to think about the brain and to think about mental illnesses. So I would like to conclude with saying that I agree with President Obama. I think that the era of the brain is upon us, but we need everyone involved to advance the study of the brain. We need the computer scientists to give us faster and more accurate models of the brain. We need the charities and businesses to keep investing in brain research at all levels. And we need the biologists and geneticists to piece together the blueprint for the brain. But more importantly, we need you. We need you to think about what the brain does and how it actually works, and think about what mental health actually is. We need you to think beyond labels, beyond boxes and prejudices. We need you to talk openly about mental illnesses and mental health. But most importantly, we need you to come up with new questions and come up with new frameworks so that we can build this era of the brain together. Thank you. I don't have a mental illness, so it's okay to ask me stuff. Don't be worried about that.
So, someone?
Yes.
Okay, we have a question.
Hello, thank you for your wonderful presentation. My question is related to what are you doing now, meaning what researchers are you particularly involved in?
Okay,
Can you hear a little bit about it? Thank you.
So, like Sarah has said, I actually work on developmental disorders and language disorders in particular. So my current research studies dyslexia, which is a reading disorder. And I use all of the methods that I've mentioned before. So I use fMRI and DTI especially, and also with network analysis. And what we're trying to do is to, like I said, move beyond labels. And instead of trying to always fix someone that has a mental illness, we're trying to actually discover in the brain which networks they might actually use. So instead of saying that, these people with mental illnesses or learning disorders are somehow broken that we need to fix, we're trying to reframe them and say, well, these are people that have different networks in their brain and they use different connections to do things. So instead of them trying to make them normal, we should rely on those networks that they use more in order to help them and provide better therapies.
More questions?
Couldn't it be that these, let's say, early mental disorders in young people could be just genetic?
Mm-hmm.
And also, wouldn't it be perhaps more useful if we study what causes illness in adults, like the real cause from the outside world that we live in?
Yeah, that's a very good question, and that's a question that we're obviously all curious about. But when doing exactly that and studying those questions, we don't actually get any further, because genetics is a very complex thing, as I'm sure Elena will tell you later. But all the research currently done with genetics actually found that we cannot put all these disorders onto certain genes. It's a very complex interaction between genetics, your environment, and also how resilient you are yourselves. And that resilience has to be an emergent property of how your brain has developed and the plasticity within the brain. So that's the first part of your question. And also, studying adults while looking at developmental disorders is very tricky because adults have gone through a lot in their lives. And the way we study them now is by testing them at a particular time, at a particular age. And if you then want to extrapolate that result to how the brain develops, that's really hard. Because you could not have followed that adult throughout his or her entire life. How can you then say the same experience that has led to a mental illness in that particular person will be the same one for children that are still developing? So again, we're trying to get there, but still a bridge too far for the time being.
Okay, thank you, Merina, very much. It was really interesting. Thank you.